sharper vision through focus. Qwen 3VL's performance looks markedly different when it can look closer. Users report the open Qwen 3VL 30B model improves recognition accuracy and reduces hallucinations when paired with a zoom-in tool that programmatically crops and inspects subregions, a technique akin to what earlier visual reasoning agents did. The Qwen team even publishes a reference Think with Images recipe, and practitioners note pragmatic quirks. Model Context Protocol (MCP) isn't great with images yet, so some setups pass image files by path rather than over MCP, and llama.cpp can return tool images via image URL in responses. The pattern is straightforward. Give the model the pixels it needs at the resolution that matters, and it does better. The newest small Qwen release raises the ceiling from the other side. Qwen 3VL 2B Thinking advertises stronger agentic interaction, operating GUIs, deeper spatial reasoning, 2D grounding, and steps toward 3D, a native 256K context expandable to 1M, improved OCR in 32 languages, and better long video understanding with tighter text timestamp alignment. Architecture updates include interleaved MROP for long horizon video, deep stack to fuse multi-level V features for finer detail, and enhanced multimodal reasoning for STEM tasks. For developers, it suggests a pragmatic blend. Better model priors plus procedural tools like zoom in often beat either alone. OCR is getting the same specialize and speed up treatment. Light on OCR 1B targets document understanding end-to-end, no external OCR pipeline, and claims state-of-the-art accuracy in its size class while being 5 times faster than DOT's OCR and under $0.1 per 1,000 pages at 5.7 pages per S on a single H100 with easy VLLM serving. Meanwhile, a GGUF build of DeepSeek OCR runs simply on CPU-GPU for local workflows, underlining how much capability is now available offline. For geospatial pros, a specialized satellite model, Olmo Earth V1 Large, also landed for on-prem analysis, rounding out a week heavy on domain-specific multimodal tools. Local runners get management layers. On Apple Silicon, MLX Knife 2.0 turns the reference scripts into a managed experience. It adds a JSON API on every command for automation, runtime compatibility checks to catch broken models, proper exit codes, and an OpenAI-compatible server built on Fast API with supervision, hot swap logging, token guards, and stop token fixes. It's positioned as lifecycle tooling, pull, list, show, health, on top of MLX caching. Vision support is still the missing piece. The maintainers are scoping how to accept image payloads in the CLI JSON API once pre-processing hooks stabilize. Windows tinkerers get a different kind of help. A tiny Vascurabat HTML utility that generates llama.cpp server launch parameters, organizes flags into groups, and acts as a searchable, portable cheat sheet. Paired with llama.cpp's own web UI and the ability to return images from tools via image URL, it lowers the friction of spinning up multimodal sessions with the right toggles, especially for newcomers. It's hobby grade, but sometimes that's exactly what makes it approachable. Under the hood, the which server debate clarifies by use case. Apple's MLX LM.server already exposes V1 endpoints and can hot swap cached models per request, which is great if you just want a thin runner. MLX Knife re-implements the server side to add cache management, structured errors, and supervision for teams juggling multiple models in CI. This is the pattern across local stacks now. Reference runner for simplicity, managed service for consistency. Protocols, skills, and costs converge. A proof of concept brings Model Context Protocol (MCP) directly into the native Ollama app, letting it connect to external tools and data sources. The community response is predictable. Ship it, because MCP makes tool access systematic rather than ad hoc, and an in-app integration removes glue code many people write on their own. For anyone standardizing agent toolchains, this is low-friction leverage, but abstractions are still awkward. A lively thread argues that skills sit uncomfortably between RAG and custom GPTs. They're markdown bundles you manually manage, weak at auth, hard to discover, and silly to distribute. The takeaway is not that skills are useless, but that they need a protocol layer, again MCP, and a real package ecosystem. One commenter is already building a prompt package manager to address discovery and versioning. It's telling that even fans see skills as sub-agents that immediately call MCP servers rather than as static snippets. Cost transparency is the other missing layer. A developer proposes native, smart LLM routing in OpenWeb UI with a standard JSON summary of which models were invoked, how many tokens each consumed, and exact dollar spend. The schema covers router and completion invocations, token counts, and costs, turning a chat UI into a spend dashboard. Others point out you can do this today via LiteLLM and custom filters, but standardizing the output would make routing reproducible and shareable across the community. Agents. Ensemble beats assembly line. Agent orchestration works better when it's less rigid. One practitioner finds that strict prompt chaining and hierarchical DAGs often underperform compared to agents that observe each other in real time, negotiate, and treat disagreement as a useful signal, a band rather than a factory line. Another describes a network-coordinated setup where SQL, RAG, coding, and charting agents collaborate on terabyte time series analysis, with a tool calling LLM handling intermediate channels. The common thread is emergent coordination over brittle scripts. Production teaches hard lessons, though. One team reports frequent agent failures on edge cases, regressions after prompt changes, and non-determinism that made unit tests nearly useless, until they moved to simulation-based testing. Programmatically generating scenarios across personas, adversarial inputs, and multi-turn flows allowed reproducible debugging and continuous regression protection, cutting agent bugs by about 70% in a quarter. It's not glamorous, but it's the kind of discipline that keeps agent systems shippable. The broader consensus in industry conversations is co-intelligence. A widely shared take notes that current agents are fast but not strong enough alone and overly code path-minded. Pairing them with humans improves outcomes. One striking stat from the research discussed: agents deliver results 88.3% faster and cost 90.4 to 96.2% less than humans, even if quality still needs oversight. Commenters argue the right KPIs are percent of steps safely delegated, human verification cost, and fabrication rate. Teaming beats autonomy for now. Coding speed meets local generation. Cerebrus Code is pushing raw throughput for coding workflows with GLM 4.6 at 1,000 tokens per second, claiming top results on the Berkeley function calling leaderboard and parity with leading models in web dev tasks. The service plugs into popular AI coding tools, Klein, RuCode, OpenCode, Crush, and offers tiered daily token budgets, aiming for stay-in-flow latency while leaving developer workflows unchanged. For agentic coding, that kind of speed often matters more than single benchmark bragging rights. On the creative side, the local edge community continues to shrink the hardware footprint. Rolling forcing demos multi-minute real-time video generation on a single GPU by anchoring temporal context, while Infinity Star 8B targets high-resolution image video generation that fits prosumer cards. Bindweave brings subject consistency to desktop pipelines, and Comfy UI support makes it usable for non-researchers. The through line is clear: quality inching up, hardware demands inching down. For audio editing and coding assistance, these gains converge. Fast code models slot into IDEs and agents. Efficient video and subject-consistent tools unlock workflows that used to need a cluster. As these pieces mature, expect multi-agent systems to treat them as callable band members rather than monolithic steps. Speech research, editing, and on-device TTS. A new paper introduces focal codic stream, a streaming low bitrate speech coding approach via causal distillation, aiming squarely at real-time communications constraints. While details will matter in evaluation, the framing aligns with a broader push toward models that work within latency and bitrate budgets, not just offline quality. Those budgets now extend to editing, not just synthesis. Step Audio Edit X 3B provides text-driven control over emotion, style, breaths, and laughs, with open weights that run on a single GPU. It's the kind of tool that makes fine-grained post-production feasible locally, integrating into creative stacks without cloud lock-in. Voice generation is landing on devices too. VNU TTS delivers Vietnamese TTS with instant voice cloning at 24 kHz and real-time CPU inference, with a next version in training on 1,000 hours to support bilingual Vietnamese plus English synthesis while preserving speaker identity. The repo includes a Gradio app, long-form chunking, and clear best practices. Keep inputs 250 characters to fit a 2048 token shared context. Use eSpeak-NG for phonemization. For privacy-first assistance and embedded systems, that's a practical path today. Multi-tenant SaaS from your database. Kubernetes now has a purpose-built operator for database-driven multi-tenancy. Tenant operator reads rows from a data source, MySQL now, PostgreSQL in v1.2, and turns each active record into a fully provisioned tenant stack using Go-templated manifests and server-side. Apply for reconciliation. It supports cross-namespace provisioning, drift detection, finalizers, and built-in metrics, with status reflection every 30 seconds and deployments reported to scale to 1,000+ tenants via concurrent reconciliation and caching. Compared to Helm or GitOps, this approach treats the database as the source of truth for tenant lifecycle, which matches many SaaS architectures better than per-tenant values files or static manifests. The docs are explicit about sharp edges, deleting registries, templates, cascades, deletions, install Cert Manager for webhooks, and provide a quick start, including Cert setup and Helm install. It's opinionated, but it fills a real gap. Cost visibility belongs here too. The same week, an OpenWeb user proposed a standardized router output schema listing each model invocation and its tokenized dollar cost, essentially turning a UI into a spend ledger. In multi-tenant contexts, such standardized breakdowns make showback-chargeback feasible for AI workloads without bespoke accounting. Diffusion text models and the energy angle. A diffusion-based LLM architecture is drawing attention. A LinkedIn analysis highlights Inception Labs' Mercury, a diffusion text model claimed to be comparable to frontier LLMs, 5 to 10 times faster, and likely more energy efficient, with a second iteration and $50 million funding that includes notable backers. The post adds that XAI is working on similar diffusion reasoning models and links to independent reviews, including one exploring analog computing fit. Even the author, though, notes hallucinations remain and that comparisons aren't apples to apples given different middleware. Skepticism and curiosity both warranted. The potential appeal is unification. Diffusion already underpins modern image-video generation, so applying it to text could consolidate multimodal modeling and possibly improve latency throughput trade-offs. That said, until head-to-head evaluations include retrieval, tools, and safety middleware, comparable to SOTA should be read as an early-stage performance envelope, not a settled replacement. The week's local roster of efficient video and AR generators underscores how rapidly Diffusion continues to iterate in adjacent modalities. If Diffusion LLMs do deliver lower energy per unit of work, the implications would be technical and economic. Cheaper inference, smaller hardware, broader access. The bar for proof is high. Rigorous, transparent benchmarks will matter more than venture headlines. For now, it's a promising direction to track, not a reason to rewrite stacks. Industry consolidation and retro computing. AMD's latest risk disclosures call out the growing Intel-NVIDIA alignment as a business risk, citing intensified competition and pricing pressure. It's a reminder that AI hardware isn't just about flops. Partnerships can shift supply, reference designs, and ecosystem gravity, altering bargaining power for everyone upstream of developers. Watch this space. Competition dynamics rarely stay static for long. Meanwhile, hardware nostalgia shows how far efficiency has come. A project squeezes an industrial Pentium PC104 board into a handheld with an SLA-printed case, VGA display, compact flash storage, Logitech trackball, and split mechanical keyboard, all running Windows 98. The comments double as a history tour. Early USB's instability, DOS-era peripheral ports, and the stackable PC104 ecosystem. Charming, yes, but also a foil to today's prosumer GPU local AI rigs. And as power centralizes, the governance lens matters. A reflective essay warns that the human drive toward order can slide into totalitarianism when amplified by modern tech. Brain chips, pervasive surveillance, social credit, programmable money, shifting control from persuasion to intervention in the inner life. The argument borrows from Huxley. The safe path lies between laissez-faire and overreach, with dignity and spontaneity protected. It's not a product update, but a useful calibration when building systems that mediate people's choices.